Okay, so we can start now. Welcome to quantum mechanics live sessions. So this course is being instructed by Professor Ramadevi and myself Archana. I'm a PhD student at the Department of Physics of IIT Bombay. Okay, so we are going to solve basically the previous year questions. So this is the first question. Suppose in a double slit experiment, the waves emitted by slits 1 and 2 are represented by psi1 and psi2 respectively. What would be the intensity produced on the screen when both slits are open? Okay. So do you know the answer to this question? Can someone respond? Maybe on the chat box, or if you prefer, you can unmute yourself and answer. Okay, so what happens is that when both the slits are open, that's correct, yeah, option D. When both the slits are open, we will get interference pattern, okay, at the screen. So if we are not doing any measurement close to these slits, or basically we are not trying to detect which slits the particle is going through, then we will get interference pattern on this screen. And the intensity is basically mod square of both the probability amplitudes, sum of the probability amplitudes. So that gives option D basically. But if we do some measurement, then this interference pattern will no longer be there, and we will get a single block. Okay, so option D is correct here. Second question, we consider a photon that scatters from an electron at rest. If the photon scatters at an angle 60 degree with a wavelength lambda prime, that is 4 times the incident wavelength, then the angle at which the electron recoils will be what? So what we need to do is basically momentum conservation. So a photon coming in with wavelength lambda, it hits an electron at rest, then this is a scattered photon, let's say, and it makes an angle 60 degree, and suppose the electron recoils along this direction, call it phi maybe, and then this is theta. Okay, so momentum of the photon, and let's call it P, and this is P prime, and this is momentum of the electron. Then if we do momentum conservation along x and y direction, this is P prime sine phi, then along x direction it is Be cos theta, and also P prime cos phi. So momentum conservation along x, let's say. Initial momentum is momentum of this incoming photon, and final momentum is momentum of the electron along x direction and momentum of the scattered photon along x direction. Okay. If we divide these two equations, we'll get tan theta is equal to p minus p prime cos phi divided by p prime sin phi. Sorry, the other way around. So sin phi is equal to, sin phi divided by p over p prime minus cos phi, and phi is the angle at which the photon scatters. So this is equal to sin 60 degree. Lambda is the wavelength of the incoming photon and lambda prime is wavelength of the scattered photon. So p over p prime is nothing but lambda prime over lambda minus cos 60 degree. And it's given that lambda prime is equal to 4 lambda. So what we get is square root over 3, 4 minus half root 3 divided by 8 minus 1, 7. So theta is the angle at which the electron recoils, so that is tan inverse square root 3 over 7, and it turns out to be 13.9. It's fine, it's pretty straightforward. If you have any questions, you can ask. Now for a particle in a one-dimensional box, consider the ground state energy to be E0. The energy spectrum of such a particle will not allow energy equal to, which option do you think is correct? Yeah, that's right. 2E, yeah. So you know the energy spectrum for a particle in a one-dimensional box. Okay, just for completeness. So what we do is minus h cross square over twice m d2 psi dx2 plus v psi is equal to E psi. So for a particle in a one-dimensional box, potential will be 0 inside that box. Potential is 0 inside the box and infinity elsewhere. 0 and x equal to a, let's say. So if we substitute potential to be 0 and we solve this Schrodinger equation, consider this to be some k square psi, then the solution is sin kx plus b cos kx. But we know wave function has to be continuous at x equal to 0 and x equal to a. Since the particle can never be on these regions where there is infinite potential, it can never cross these barriers. So their wave function is always 0. So we need to impose the condition on the wave function that it should vanish at x equal to 0 and as well as at x equal to a. So those are the boundary conditions. If we if we take x equal to 0, then we get b. So b has to be then 0, and so the wave function then becomes a sine kx. Moreover, at x equal to a, it has to be 0, and that implies sine ka should be sine some integer multiple of pi. So k should be n pi over a. Therefore, the wave function, which depends on n, is a sine n pi x over a. Okay, and then we also need to normalize the wave function. So for that, we just take mod square of the wave function and integrate over the region where the wave function is non-vanishing and equate it to 1. So from there we get mod a square and if you do the integration, this will give us sine, sorry, not 0 to L, but we have chosen the region to be from 0 to A. So the second term will vanish because we will get sine from this term, and normalization constant is nothing but square root 2 by A. So wave function for a particle in a one-dimensional box is so this was a condition on Kn, and K was nothing but Kn square was 2me over h cross square. So from that we get the energy spectrum to be h cross square Kn square divided by twice m, that is n square pi square h cross square divided by twice m a square. So, and it is important to note that n starts from 1 here, because if you consider n to be 0, then wave function will be trivial, it will be 0. That is not what we want. So therefore the ground state energy is E1, or we can call it to be E0, but actually it corresponds to E n equal to 1, that is pi square h cross square divided by twice m a square, and any other energy will be n square E0. So basically you will never get 2E0 because n is always an integer. So for n equal to 2 you will get 4E0, n equal to 3 gives 9n0, E0, and so on, 16E0, n equal to 4. So this is the correct option, as two of you mentioned. Okay. Now consider a particle in a two-dimensional box whose ground state energy is epsilon naught. Then the energy E equal to 13 epsilon naught is non-degenerate. Can you answer to this question? Is it true or false? What is the energy spectrum for a two-dimensional box, for a particle which is in a two-dimensional box? So here we need to solve the two-dimensional Schrodinger's equation, right? So again potential is 0, but now we will get two differential equations. Is it satisfying? Yeah, I mean, so the question is this energy non-degenerate? What do we mean by that? So when we say that a particular energy is degenerate, what do we mean by that? Corresponding to that same energy, suppose a particular energy E is twofold degenerate. Then what does that mean? We have two different wave functions, psi 1 and psi 2, both with same energy eigenvalue E, meaning Hamiltonian acting on psi 1 is giving E psi 1, also Hamiltonian acting on psi 2 is giving E psi 2. Then we say that this energy E is twofold degenerate. There are two different wave functions which have the same energy eigenvalue. Now what happens in a particle in a two-dimensional box is that the wave function, so should I derive this wave function, or you are familiar with it? Do you want me to derive it? Then I will do that. Okay, let me do that then. So this is the so this is a two-dimensional box, meaning we are in a two-dimensional plane. Let's call, oh god, x, y. So potential is now is a function of x and y, but it is 0 within 0 to a along x as well as along y, and it is infinity elsewhere outside that region. Okay, so we are going to then solve for the spectrum and the wave function for a particle which is in this kind of a two-dimensional infinite square potential. So v of x, y. So wave function should now be a function of x and y. So inside the box, this term will be 0. Now we can use separable solution, that is, so what was the condition? Whenever the potential can be broken down as some potential along x plus some other potential along y, then we can use separable solution. That is, we can write psi xy as some function of x times some function of y, and for this two-dimensional box this potential is 0, so it automatically satisfies this condition, and hence we can write the wave function as product of f of x times g of y. So then from that equation what we get is so the first term will act on f of x Now we can divide the entire equation by this wave function f of x times g of x. That gives us 1 over g of y d2g dy2 is equal to e. Now we should keep all the x dependent terms to the left and y dependent terms to the right, so that we can equate it to some constant. Let's call this constant to be alpha. So therefore the two differential equations that we now need to solve is this one and h cross square over twice m is equal to alpha, correct? So what do we get? The usual solution, it's twice m alpha over h cross square f of x. Then consider this to be kx square f of x. So f of x becomes a sine kx plus b cos kx, and from that this differential equation we will get twice m e minus alpha divided by h cross square g of y, and call it ky square gy. So this again gives us some other constant, let's say c sine kyy plus d cos kyy. Now we again need to put those boundary conditions, that is the wave function should be 0 along this boundary, this entire boundary. So if at x equal to 0, 0 would imply b is equal to 0, and if at x equal to a equal to 0 would imply sine is equal to sine n pi, or kx is equal to nx pi a over nx pi over a. So f of x is equal to a sine n pi x over a. Likewise, the same boundary conditions you need to put for g of y. So g of 0 equal to 0 would imply d is equal to 0, and likewise when we consider g of a equal to 0, that would give you k of y is equal to ny pi over a. So c sine ny pi over a. So what is the wave function then? product of these two, f of x and g of y. Let's call some other constant a prime, sine nx pi x over a, sine ny pi y over a. Okay, now this a prime can again be determined using this condition. Now you need to integrate over both dx and dy. And since there are two sine, so you will get two factors of 2 over L. Like for before, when we are solving one dimensional box, it was just 2 over L, but now it will come 2 over L whole square when you do the integration. Sorry, sine square ny pi y over L dy. Both ranges from 0 to a. So from that term you get a, and from this integration you get a, and from this integration as well you will get another a. So a prime is equal to 2 over a. Fine. So the wave function nx ny is 2 over a sine nx pi x over a sine ny pi y over a. Okay, and kx is this nx pi over a, and what was kx square? It was 2m alpha. So kx square was 2m alpha divided by h cross square, and ky square was 2m e minus alpha divided by h cross square. So if you sum them up, you are left with 2me over h cross square. Okay, now kx was nx square pi square over a square, ky is ny square pi square over a square. Let us put subscript nx and ny because energy is going to depend on those two values. So from there we get the energy spectrum to be h cross square over twice m a square pi square nx square plus ny square. Okay, so for the ground state, again both nx and ny should be 1. Let's call this some energy unit, I think epsilon 0. Then the energy spectrum can be written as times epsilon 0. So the question says whether this energy 13 epsilon 0 is degenerate or not. As one of you has Yeah, it is degenerate. So how is it degenerate? So when nx is suppose 3 and ny is suppose 2, right, then energy will be 3 comma 2 will be, yeah, right, so 3 comma 2 will be 13, right, 9 plus 4 epsilon 0. But you will get that same energy when you consider nx to be 2 and ny to be 3. So what does that mean? Your wave function will be different for both the cases. So when nx is 3 and ny is 2, what is the wave function? So this wave function will be then 2 over a sine 3 pi x over a sine 2 pi y over a, right? And when the wave function is nx is 2 corresponding to nx2 and ny 3, what will it be? 2 over a sine 2 pi x over a sine 3 pi y over a. So you can see there are two different wave functions corresponding to same energy eigenvalue, which is 13 epsilon 0. So that's why 13 epsilon 0 is degenerate. This is the degenerate eigenvalue. Is that fine? Okay. So the statement is false. Okay. Okay, now this problem involves a cubical box. So particle in a cubical box. Suppose the fifth energy level is given by 12 Eg, where Eg is a ground state energy. Okay, so by the way, for this problem, the question says epsilon 0 is the ground state energy and then E is this much. But I think epsilon 0, if it is the ground state energy, then it would have been, if it is ground state energy, then it would have been h cross square pi square divided by twice m a square, then 1 plus 1. But I think that is not what we are referring to, epsilon naught, because then this will be 13 by 2, I think. So epsilon 0 here is the energy unit, meaning this entire thing, h cross square pi square divided by twice m a square, and not just h cross square pi square divided by m a square. Okay, now this question says, suppose fifth energy level of a particle in a cubical box is given by 12 Eg, where Eg is the ground state energy, then the immediate sixth energy level will be how many fold degenerate? Do any of you have answer to this question? So now we know the trend, right? The wave function and the energy spectrum. So we have solved it for a two-dimensional box. Now we can easily extend it for a cubical box or a three-dimensional box as well. So let me just write the wave function and the energy spectrum. So nx, ny, nz, it is a function of x, y and z. Now so the normalization condition, normalization constant now will be 2 over a to the power 3 by 2. So for two-dimensional box it's just 2 over a. Threefold degenerate, you think? No, the question is not the degeneracy of 12 Eg. The question is degeneracy of the sixth energy level. So 12 Eg is the energy for the fifth energy level. Can you do it for the sixth level as well? So the wave function is sine nx pi x over a sine nz pi z over a, and the energy spectrum nz h cross square pi square divided by twice ma square okay. So let's do it then. First energy level, nx, ny, nz all should be 1 or 0. So again, you don't need your wave function to vanish. So nx, ny, nz all start from 1, then all the integer values. So first energy level would correspond to both three of these should all be 1, okay, 1 1 1. For the second level, what can you have? You can have 2 1 1 or 1 2 1, or you can also have 1 1 2, because so second level is basically threefold degenerate, because each of these will give you a different wave function, but the energy will be whatever it will come if you consider nx to be 1, ny to be 1 and nz to be 2. Third level, what will it be? 2 2 and 1, right? Or like before, 2 1 and 2, or 1 2 and 2. So this is again threefold degenerate. What about fourth level? Can someone tell me what will be the nx, ny and nz for fourth level? Should it be 2 2 and 2 or what? So suppose you consider 2 2 and 2. The energy that you will get, suppose again this is epsilon 0 energy unit, nx square plus ny square plus nz square, then 2 2 2 will give you energy to be equal to epsilon 0 12 epsilon 0, right? But from the question itself you can see it's not the case. So fifth energy level corresponds to 12 epsilon 0. So what should be the case for fourth level? What should be nx, ny and nz? Well, it should be 3 1 and 1.
That was coming 12 1, so it will be in fourth level. I confused that. We have calculated the 12, right? For fourth level. So given as a 12 in question,
yeah,
it is given energy is equal to 12 easy. So it should be for fourth level.
No. So see, when so I was saying, if you consider 2 2 and 2, you are getting 12 epsilon 0. Yes. But suppose you consider 3 1 and 1, you will get lesser energy, because it will give you 9 plus 1 plus 1, which is what? 11. So this has to be the case for fourth level, because it is giving you lesser energy, right?
Okay, so we have to find the less energy.
Yeah. That's how you should figure out what should be nx, ny and nz.
Okay.
Yeah. Likewise, you can have nx to be 1, ny to be 3, nz to be 1, and nx to be 1, ny to be 1, nz to be 3. Okay. Yeah, now fifth level would correspond to 2, 2 and 2, that's 12. And fifth level, sixth level, what will it be? Yeah, it should be 3, 2, 1, exactly. So now can you tell me what is the how this question, the immediate sixth energy level will be how many fold degenerate? Can you now answer? So you now know that nx can be 3, ny can be 2, nz can be 1 for sixth level.
Ma'am, is it a threefold degenerate?
Do you think it's threefold? But can you give it little more thought? So you can have 3, 2, 1 as well as 3, 1, 2. So there are three integers and each of them are different.
Six-fold degenerate. Each pair can be interchanged in between.
Exactly, it's six-fold degenerate. So you can have 3, 1, 2, or you can have 2, 3, 1, 2, 1, 3. Likewise 1, 3, 2 and 1, 2, 3. So sixth level is six-fold degenerate. You are correct. Okay. So this page is not required.
Ma'am, how do we know we have to go till 16 generation? We can bind up till 5 also. No?
You can say that again.
Just I'm asking that how do we know we have to just going further and further to know till the degeneracy of the system? We can bind up till 4 or 5 only.
No, so this question, why did we go up to sixth level? The question says that, like, it is asking the degeneracy of the sixth level energy, sixth energy level. Correct. That's why we went up to sixth level and see what will be the degeneracy.
Ma'am, we have find the six-fold degeneracy, but we don't know that will be a six-fold degeneracy only.
Yeah, you now know. I mean, see, nx, ny, nz, all three should be 3. I mean, all three can be either 3, 1 or 2. Other than that, you cannot have anything. You tell me what would you expect? Anything else that will give you. So what is this energy for sixth level? Sixth level is 3 square 9 plus 4 plus 1 epsilon 0. So it's 14, right? 14 epsilon 0.
Yes.
So can you tell me nx, ny, nz, which will be 14 other than these 6 combinations? So suppose you take 3, 1, 1, but that is already fourth level, right? Meaning it has energy 9 plus 1 plus 1 epsilon 0, that is 11 epsilon 0. So you can't have this. So if you are suppose thinking nx is 3, ny is 3, nz is 1, that will not give you 14 epsilon 0, that will give you higher energy. So that is higher energy level, excited level.
Okay, so just like there is a 14 epsilon now, so we should go till 12 epsilon now, right? Because it is given ground energy of 12 epsilon now. Sorry, E is given 12 E easy.
No, okay, so let's read the question again. It says, suppose fifth energy level of a particle in a cubical box is given by 12 epsilon 0. Here again it says Eg is the ground state energy, but I again think it should be this h cross square pi square over twice m is a square, because Eg here, what is Eg? So ground state energy is equal to h cross square pi square over twice m a square into 3, right? 1 plus 1 plus 1, 3.
Yes.
Whereas for fifth level, energy of fifth level is equal to h cross square pi square over twice ma square into 3 times 4, so that is 12. So this energy level, you can see, is not equal to 12 times E of ground state, because E of ground state has this 3 multiplied with it. So this epsilon 0 should again be the energy constant, that is this term only, this epsilon 0. Okay, having said that, so this 12 epsilon 0 is the energy of the 5th level. It is, I mean, the question is telling you, see, this is the 5th energy level. Now you need to find out the degeneracy of the 6th energy level. So that's what you need to do. I mean, you could have looking at 12, you could have guessed what should be nx, ny and nz.
Okay.
Right? So you already know that 5th energy level is 2, 2 and 2. You don't have to start from 1st and go up to 6th. You start with 5th and then figure out what should be the 6th energy level, nx, ny and nz.
Okay.
Yeah. Is it clear? Otherwise I'll explain again maybe. You understand? Yes?
Yes, ma'am, clear.
Okay. Okay, now 6th question says, this is the wave function for a particle at time t equal to 0. What do we need to figure out? The normalization constant A in terms of these constants A and B. So what is the normalization condition? Mod of psi square over the region where the wave function is non-vanishing should be equal to 1. So here the region is from 0 up till A, up to B. So 0 to B, mod of psi square dx should be equal to 1. So this implies 0 to A, mod A square x square over A square dx plus again same A, mod A square A to B, b minus x whole square divided by b minus a square dx is equal to 1. So from this you need to figure out, do the integration. Okay, so a square, this will give you x cube over 3, 0 to a plus whole square, and this will give you minus of b minus x whole cube over 3, a to b. So times a cube over 3 plus 1 over 3 okay, so when I substitute b it will be 0, and for a I will get b minus a whole cube, correct? So mod of a square a plus b minus a over 3 is equal to 1. Yeah, correct. Square root 3 over b. Is the normalization constant. Square root 3 over b, so option D. Okay. Okay, now for this question we need to solve infinite symmetric square well potential, but it is again one dimensional, but now it is symmetric. So let us solve it. So okay, now this is again an infinite potential. So the potential is infinity. So potential is infinity everywhere beyond x equal to minus a by 2 and x equal to a by 2, and it is 0 inside that region. So v of x is equal to 0 in this region and infinity elsewhere. So particle is again bound to remain within this region, minus a by 2 to a by 2. Okay, so Schrodinger equation with Vx is equal to 0 gives us, plus Vx, but I am not writing that because it's 0, psi of x is equal to this implies psi dx2 is equal to minus twice me over h cross square psi. So let's consider it to be some k square. So you know the solution is linear combination of sine and cos. Now the boundary condition is a bit different. So far whatever we have done is same as that of the infinite potential when it ranges from 0 to L. I mean when the potential is 0, between 0 and L, this is what we do. But now the boundary condition is different. So wave function has to vanish at x equal to minus a by 2 and x equal to a by 2 for the wave function to be continuous. Since the particle can't be here because of infinite potential elsewhere beyond minus a by 2 to a by 2, wave function at all these regions should be 0. So that means wave function should be 0 at these boundaries as well. So the boundary conditions psi x is equal to minus a by 2 is equal to 0 as well as psi at x equal to a by 2. Okay, so let's see when we substitute a by 2. This is equal to 0 minus a sine ka by 2 plus b cos ka by 2, because cos will remain positive even if the argument is negative. So these are the two equations we get from the boundary conditions. Now let us add 1 and 2. What are we going to get? This will give us 2b cos ka over 2 equal to 0, or cos ka over 2 is equal to 0. So what should be the argument of cos when it has to be 0? It should be n plus 1 pi by 2 for n equal to 0, 1, 2 and so on. So this implies k is equal to, let's put a subscript n because k depends on n. So k is equal to 2n plus 1 pi over a, where n is from 0, 1, 2, everything. Now we can rewrite it as m pi over a, where m takes values. So suppose you substitute n equal to 0 here, what do you get? 1. You substitute n equal to 1 here, you get 3. So this I am replacing with m and saying that m runs over odd integers, meaning 1, 3, 5 and so on. I'm writing it as km. Okay. So the wave function is then equal to a cos km x over a when m is odd. Okay, now when we subtract 1 and 2, what do we get? We get 2a sine ka over 2 is equal to 0. So what does that imply? Sine ka over 2 should be equal to sine n pi, where n again should start from 1. Okay, sine 0 is 0, we know, but for the wave function to be non-trivial, that it should not vanish, we need to start n from 1, 2, 3, so on. So this implies kn is equal to twice n pi over a, where n is equal to 1, 2 and so on. So we can rewrite this in this form so that it looks better. So you can write it as m pi over a, where m is, so when n is 1, 2n is 2. So that's how we are doing this. So m is 2, 4, 6 even values. So basically psi of m x is equal to b sine km x over a when m takes even values, 2, 4, 6 and so on. So basically psi of x, you can write a cosine m pi x over a for odd values of m, and it is equal to b sine m pi x by a when m takes even values, right? And okay, so that's what we need. So the question is, particle of mass m is in an infinite symmetric squirrel potential with walls at x equal to minus a by 2 and x equal to a by 2. Wave function psi n of x for n equal to 1 can be written as, so for n equal to 1, then which one should be the case? Cos. So for psi 1 of x for the infinite symmetric squirrel potential is a cos pi x over a. Okay, you also need to do the normalization, but you now know it will come out to be square root 2 by a if you do mod psi m x square dx equal to 1 and integrate over it from 0 to, no, not from 0 to a, but minus a by 2 to a by 2. You will get a to be square root 2 by a. You get my point, right? So mod square dx minus a by 2 to a by 2 should be equal to 1. For both these wave functions you can do separately and you will get the same answer, namely a is equal to b is equal to square root 2 by a will be the answer. So psi 1 of x is basically square root 2 by a cos pi x over a. Fine. So that means the correct option here is A, option A. I hope it's clear. Okay. If no questions, I'll go to next problem. You are familiar with the particle in a box with this wave function, where A represents the side of the box and the potential is 0 for x lying between 0 and A and infinite elsewhere. The statements which best describe such a particle are, can you answer to this question? Someone? So this is for
each function has n minus 1 nodes. It is the MSQ type question?
yeah.
Okay.
Multiple choice, yeah.
And also B, the wave function correspond to different energy level are orthogonal.
Okay.
And it is non-degenerate.
Yeah.
And also D. So A, B, D, I think.
D says energy between adjacent levels is constant.
Yes.
You
I think no. So.
Yeah. What was the energy spectrum for a particle in a one-dimensional
Okay,
box?
n square pi square h cut square upon 2ma square.
Exactly.
I think no. So A and B, sorry.
Yeah. Correct. So let me explain it for others. So psi n is given to us, and it says each function has n minus 1 nodes. So by nodes, what do we mean? So this is the infinite potential, one-dimensional infinite potential from 0 to A. Potential is 0 and potential is infinite everywhere else. Okay. So this wave function, we have derived it by putting the boundary condition that it should vanish at 0 and A. So for n equal to 1, we get the ground state wave function. So what is ground state wave function? Psi 1 of x is equal to square root 2 by A sine pi x over A. So at x equal to 0, it's 0, and also at x equal to A, it's 0. It has to be, because that is how we have solved it. But between 0 and A, it will never be 0. Do you agree with that? Whatever value you put suppose A over 4, what will you get? Sine pi over 4 you will get. Is that 0? No. Likewise, if you put A over 2, it will be sine pi by 2. So it will never be 0. So the ground state wave function then looks like this. So there are no nodes, meaning for n equal to 1, number of nodes is 0. Likewise, if you suppose now consider n to be 2, then you get first excited state, and the wave function corresponding to it is square root 2 by A sine 2 pi x over A. So again, this vanishes at x equal to 0 and x equal to A, which is obvious. But now if you substitute x is equal to A by 2, so this will vanish, right? So it has one node at x equal to A by 2, and the wave function can be drawn like this. So it is a sine wave, sine 2 pi x by A between 0 and A. Oh god, sorry, just give me a moment. Yeah, so for first excited state we have one node, that is for n equal to 1. Number of nodes is 1. Likewise for n equal to 3 you will have 2 nodes and so on. So that's why this option is correct. Each function psi n of x has n minus 1 nodes. Now second option says the wave functions corresponding to different energy levels are orthogonal. Well, that's true. You can verify it if you are not convinced. So basically you can, what does orthonormal mean? So psi mx star, but these are not complex, so I can remove that star. Psi nx dx, when m is not equal to n, it should give you 0. From 0 to a if you integrate it. So basically 2 by a.
Ma'am, we can use direct chronicle delta notation here.
Yeah, this is actually equal to chronicle delta.
Yes.
Yeah.
So it is easy to understand.
Yeah, but how do you get this chronicle delta? Basically from these wave functions, right? Like
Yes.
if you try to integrate it, when m is not equal to n, it will be 0. But when m is equal to n, it will be 1. Because that's how we have normalized it.
It reduced the lots of time. So I think.
Yeah.
To use the chronicle.
Okay, fine. Now so maybe I can keep it there. Okay. The ground state energy of the hydrogen atom is given by E1 equal to minus R, where R is the Rydberg constant given by 13.6 electron volt. If the atom makes a transition from the excited state n equal to 2 to the ground state n equal to 1, then the radiation emitted would be. Would you like to solve this? Can someone answer me? Please explain.
Yes, I can solve, but it takes some time. 40.8 electron volt. Okay.
40.8 electron volts.
40.8.
Yes, ma'am.
40.8. Sorry, I have calculated 10.2.
I'm not sure.
Okay. So E1 is. Okay, I think Abhiram.
Actually, ma'am, the radiation emitted in terms of energy. So if you reduce the ground state and first excited state, it gives the.
10.2, madam?
Yeah, 10.2. Yes.
Yes.
So it's minus 13.6 electron volt. So atom
Another
is.
is 13.6 by 4, next one. So difference is 10. 10 point something.
Yeah. Atom is making a transition from n equal to 2 state to n equal to 1 state. So by that process, it is radiating photon. So energy of photon is E is equal to h nu, and that should be equal to, let's say this is E2 and this is E1. It should be E2 minus E1. So we know for hydrogen atom En is minus over n square. So this is minus R divided by 2 square minus of minus R divided by 1 square, and that gives h nu 1 minus 1/4. 13.6 times, yeah, someone has written it, 3/4, and this will give you 10.2 electron volt. Fine. Okay, the last question. Wave function for a free particle of mass m is given. A is normalization constant. What is the probability current? So what is the probability current? Do you know?
B square by A square.
B, ma'am.
Option B, you're saying?
Yes.
How did you calculate it?
Actually, it is exponential term, and if we take complex conjugate, they will with multiply it is 1. So only mod A square is.
What is the probability current expression, you know?
Uh,
Yeah, Mami, from there only what did I read?
Psi star del psi del x minus psi del x del psi star.
Yes. Uh,
Okay, but how do we get this probability current?
with equation of continuity.
Yeah,
From
that's
equation.
from the equation of continuity. So equation of continuity says del rho of del t plus divergence of the current should be equal to 0, and rho is the probability density and J is the probability current density. So for us, if we are given a wave function psi, what is the probability density? So probability density is mod psi square, and total probability is nothing but mod psi square dx. So if we take time derivative of it, so if we do del t of mod psi square dx, we will get, so mod psi square is psi star psi, and if I take del t inside, I will get two terms. Okay, and then I can use Schrodinger's equation to substitute here. So minus h cross square over twice m So del psi over del t is, we can replace there. So this minus I can write as I square. So minus 1 I can write as I square, and then that I on right hand side gets cancelled. I'm left with I h cross over twice m. Then this can be replaced in this equation. So we are basically trying to see what is the probability current. That is our goal. So from the Schrodinger equation, we can replace del psi star del t and del psi del t, and that will give us I h cross over twice m outside del 2 psi star. Okay, so for this term, first term, I will get negative sign, because when I'm taking del psi star del t, I will get negative sign because of this I. So minus del psi square del psi star psi plus vx, sorry, minus again psi star okay, and then there is psi here, this psi gets multiplied, and then plus psi star del psi del t, this term. So we can see, and then there is this integration over dx. You can see these two terms are getting cancelled out when you take this psi star inside. So I can write it as plus and then psi star here. So they get cancelled out, and I have minus del 2 psi star del x2 psi plus psi star del 2 psi del x dx. But this is nothing but time derivative of the probability. So del t of mod psi square dx, and the right hand side can be further written as integration del x of psi star del psi del x del psi star del x psi minus plus psi star del psi del x, because the cross terms will get cancelled out. So when you act with this derivative to these two terms, there will be term like del psi star del psi del x from both these terms, and they get cancelled out, and you will be again left with this. So you can write it this way, and so this would imply, if I take it on the left side, integration over dx, and mod psi square is nothing but probability of getting a particle at position x, then plus I h cross over twice m. Now I'm switching this sign because I'm taking it to the left, del x of del psi star del x minus psi star del psi del x is equal to 0, right? So this entire thing, so this is nothing but probability density, and this is nothing but probability current density, sorry, derivative of the probability current density. So this entire analysis we have done for one dimension. If you are doing it for 3 dimension, then this will be replaced by gradient. Okay, this will be gradient dot the current J. So for us, what is the current then? Sorry, this del t will remain with rho. Therefore, the current density is I h cross over twice m. Okay, let me write one more sentence. Sorry. This is equal to plus del x of the probability current. Therefore, probability current is I h cross over twice m psi del psi star del x minus psi star del psi del x. Okay, now for us, wave function is given to be a exponential I kx minus omega t. So what is del psi del x? It's I k a exponential I kx minus, and del psi star del x will be minus I k a exponential minus I kx minus, when you replace these two in the probability current density, you will get mod a square. Then exponential will get cancelled out because here you have plus I and here you will have minus I when it is starred. So you understand, right? Okay. For psi, and from del psi star del x we get, sorry, a I have written already here, mod of a square. So I kx minus et over h cross minus psi star exponential h cross, and then del psi del x is ik exponential I kx minus et over h cross. Okay, so exponentials get cancelled out, and mod of a square minus ik. So 2 times minus ik, and minus I times I will give you plus 1. So h cross k divided by m mod of a square is the probability current. So the right option is then, yeah, as you said, B. So we are done with this assignment. Are there any questions? If not, we can stop here and we will meet next week, Sunday at 6 p.m. Can you please share the solution PDF in the chat box? I think I have to upload it on my drive folder and then share that link with the NPTEL team, and they will provide you the link through the course web page. So you will get access to this file anyway, yeah. And also I will upload this video to YouTube, so you will get that link as well. Okay then, bye. See you next week. Thank you for joining.